Thank you. I'll present what's new in the OTP 28 release, which we released a bit over a week ago. There will be some new features for comprehensions. Generators in comprehensions, as you know them today, will from now on be known as relaxed generators. In the example here, we have the function all users, which is expected to return a list. If any elements in that list won't match the pattern on the left-hand side of the arrow, they will just be silently ignored. And that's why we now will know them as relaxed generators. As of 28, you will also have strict generators, where you write the arrow with a colon in the middle. This is an open source contribution by Daniel, who presented just before me. In this example, if all users should return something that doesn't match this map pattern on the left of the arrow, the whole comprehension will fail. You can read more about this in EEP 70 and the documentation of comprehensions. Today you can combine generators in these ways, or for example in these ways. In the first example, we create the Cartesian product of the two generators. In the second example, we feed the right generator with the elements produced by the left generator. As of 28, you will also be able to zip combine generators using ampersand between the generators. It will work similar to how lists zip work, and both of the generators are expected to produce the same amount of elements, otherwise the whole comprehension will fail. More about this can be read in the EEP and the documentation of comprehensions. In OTP 28, we extend the type language with nominal types. Nominal types are distinguished by name, as opposed to how the already existing types, which are distinguished by structure. Dialyzer have been extended to type check nominal types as well. We can look at this example from crypto. We have the specification for the sign function. Here we expect the fourth argument to be a private key. If we should pass it a public key, Dialyzer won't complain, since the structure of the public key and the private key are the same. If we replace these types with nominal types, Dialyzer will be able to detect that you passed the public key instead of a private key and complain. Internally, Dialyzer will use nominals, or is using nominals, for type checking of opaque types. This has both sped up performance of opaque type checking and will also produce better warnings. More information can be found in EEP 69 and the documentation of nominal types. In certain situations, you might want to retrieve a message from the message queue in an other order than it was received. You can use selective receive expression to fetch messages out of order. However, if the message queue is very huge, the performance cost will be large as well. In order to alleviate this, we have introduced priority messages. The receiver needs to opt in for this. We have two major scenarios. The first scenario is when other processes in the system explicitly send signals to the receiver. The receiver in this case create a priority alias by calling the alias 1 BIF and distribute this priority alias to the processes that are supposed to be able to send it priority messages. Using the send3 BIF and the priority alias, a process can send a priority message to the receiver. Using the exit3 BIF with the priority alias, it will be able to send the priority exit signal to the process. When it comes to signals triggered by events in the system, you can't use priority aliases since no process is explicitly sending the message. Today, we support priority messages as for triggered monitor messages and broken links. In order to request these as priority messages, you pass the priority option when you request these messages. When a process is received a potential priority message, it will inspect it. If it's not accepted as a priority message, it will be handled as an ordinary message and will be appended to the end of the message queue. If it is accepted as a priority message, it will overtake all the ordinary messages and be inserted just behind the last accepted priority message. Receive expressions will work as expected and begin searching for matching messages from the start of the message queue. More information on this can be found in the reference manual and EEP 76. The RE module for regular expression is up to now based on the PCRE library, which unfortunately reached end of life. So we needed to find a replacement for it. We have looked at a bunch of different alternatives, for example, Google's RE2 library, but we settled for the PCRE2 library. One reason being that this will introduce the least amount of incompatibilities. You can read more about the incompatibilities in the user's guide for standardlib called PCRE2 migration. I will mention two things here. If you don't use the Unicode mode, character classes will by default match on 7-bit ASCII and not on 8-bit Latin 1 as it used to be. Perhaps the thing that has caused most issues for people trying out the release candidate is that the term representation of a compiled regular expression changed. It used to be like the first term here, ending with the binary. The binary used to be more or less PCRE assembly code, which unfortunately isn't platform independent. So if moving this compiled regular expression to another platform, you could crash the system or other bad things could happen. In OTP 28, the last element will instead be a reference pointing to an internal structure in the runtime system where we hide the assembly code. We can, however, see that why people were pre-compiling regular expressions and pasting it into the code. And we are looking into ways to support similar things like this. So hopefully for 28.1, there will be a solution for this. Give no promises though. You will get a source software bill of materials with every OTP version as of OTP 28. The SBOM will be stored as an asset on the release tag for each version. Can be quite intimidating looking at it. It's a huge text file, about 6 megabytes. But if you know some details about it, it's not that difficult to understand the information in there. It's a JSON file, a JSON document containing one JSON object on the top level. There are mainly 3 keys of interest here. Files, where each file in the OTP repository is listed with information like licenses and the copyrights and stuff. We have divided up the repository into different packages, and under the package key you can find information about each OTP application, tests for that application and documentation, and also third-party products embedded into OTP. Under the relationships key, you can see how different packages relate to each other. And you can easily construct a tree of how the different packages relate to each other. When you deliver something based on Erlang OTP, you typically won't deliver all of OTP. For example, if you want to remove common test and isn't interested in information about common test, you can easily remove the subtree rooted in the common test package. A few optimizations that have made in 28. Scheduler scalability has been improved, specifically how task stealing works. This is an open source contribution made by Robin Morissette. And you are expected to see quite significant reduction in CPU utilization if you use a large amount of schedulers. Creation and garbage collection of funds has been optimized, so you will likely see a performance gain there if you use a lot of funds. They already previously introduced the optimization for destructive updates of records and binary appends. Will be applied in more places now. The SSL application has been optimized for TLS 1.3 application data transmission. Specifically for small packages, you will see an improvement. We've seen up to 25% improvement. And a number of new features in 28 that you might want to look closer at, which I won't talk much about. You can now use more than one system monitor process in the system using trace sessions. And these system monitors can have different configurations. We've introduced a new BIF, Hibernate 0, which makes it easier to hibernate processes, actually trivial. We have introduced two new BIFs for as replacements for the processes BIF, and using these two BIFs, you will be able to inspect the system without acquiring locks as the processes BIF does, and you will not need to move up as much memory at the time to the heap as the processes BIF did. Gets tables can now take more than 2 billion keys. You can write literal floating point based floating point literals. And this is an open source contribution by Rickard Green. The compiler will give you suggestions for fixing typos if it in a lot of scenarios. And there is a new module in standard lib for Z standard compression, and a new raw mode for implementation of custom shells and the other terminal applications. Outside of the OTP repository, you can also find an Emacs mode based on tree-sitter. It still uses the old Emacs mode part of OTP as well, but the intention here is to provide this Emacs mode as the only Emacs mode in the future, but it's under development. You can read more about what's happened in OTP 28 in the highlights blog post on Erlang.org. A few figures about open source contributions. We have merged 204 contributions for OTP, and these contributions have been made by 89 non-OTP team members, and this is contributions for OTP and not for OTP 28 and not for maintenance patches in 27, etc. So there have been a lot more contributions than this. Thank you very much for your contributions. That's it. The slides can, by the way, be fetched from this URL. I can begin by answering a question that Per Stritzinger asked during his talk. I don't know where you are, but Per asked why you can't disable the dirty schedulers, and this is by design. We don't want to have people hogging schedulers by executing native code for a long period of time, since this will mess up a lot of things like memory deallocation and scheduling, etc. So we want to have this provided all the time, so you don't have no excuse for not handling long executing native code. You can always disable it by hacking the runtime system, though.
Do we have any more questions in the room? Not, I guess we can give some more noise to Rickard.